Original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by our very own Quentin Wayrich, who is also the current astronomer in residence out at Killarney Provincial Park for York University. Very exciting. We are, just to share in the excitement, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT, if that's more your speed. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. That's right, it's happening right now if you're listening live. So if you are live, head on over to the yorku.ca/science/observatory. That's our website. Follow the links to OPV online public viewing, or click on any of the links that say YouTube, Allan Carswell Observatory YouTube channel. That will get you to online public viewing. Our observatory crew is there live as of this broadcast and will be able to answer questions and show you wonderful images. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter at our handle at York Observatory, or of course, York Universe, and Instagram with the handle York U Observatory, Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to make a donation, you can see that website I mentioned before, yorku.ca/science/observatory. Our crew is monitoring the chat room for questions and posting content right now. So if you head on over, you should be able to see some things as well as hear this broadcast. But the current weather is, well, not great in Toronto. We're seeing some dark storm clouds, and it's not looking particularly friendly for observers at the moment. Quentin, how is it out at Killarney Provincial Park?
Well, I'm sorry to say it's not all that much better here. It's overcast. We have been expecting thunderstorms for the past few days, and I don't believe any of them have ended up rolling in yet, but I'm getting a 78% chance of rain at 10 p.m. tonight. So maybe today will be the day that the rains finally do come.
Well, rain is, I mean, we can't say no to a bit of rain with all of the fires that we've had, although I wouldn't say no to some clear nights either.
I've been very fortunate. I've had plenty of clear nights out here. It's been absolutely gorgeous. I've managed to take some very amateur, but some still pretty good images of the Milky Way using actually just my phone camera. So I'm really pleased with the weather I've been getting up here. It hasn't been too hot either.
I actually have to say that if anyone listening is interested, so just a little plug, some of Quentin's fabulous photos, it will make you very jealous, from his astronomer in residence tenure so far are actually on the blog. So it's the same website I told you before, yorku.ca/science/observatory, and then you go to astronomer in residence program or /air, astronomer in residence blog. And the blog site has all of the pictures from this year's Astronomer in Residence as well as last year. So I do recall you posting a absolutely lovely starry night picture. Gosh, I would think you posted it sometime last week. It was absolutely clear, it looks like.
Yes,
so I know you had some.
First night.
Oh yeah, that was your first night? Wow, what a night.
So, yeah. Yeah, it was an absolutely beautiful night. I came in. I left home a lot later than I expected to. I ended up leaving home around noon, and I was like, "Oh, I hope I still have like daylight by the time I get out there," because last time when I did the program, I was coming in the fall. But now it's July. The sun doesn't set until 9 p.m. So I came in at a nice time. I was still able to have a hike before it got dark. And then when it did get dark, I had an absolutely gorgeous Milky Way overhead to greet me upon my arrival, and I took some images. I'm really really pleased with how it's gone so far.
Yes, well, and we're very lucky to have you up there for our program. Of course, that's not all we're here to talk about tonight, but we'll try to have you on as a guest speaker for one of our Teletube episodes on a Wednesday once you get back. Of course, the importance of clear, dark skies is something all of astronomers, I think, or all of astronomy can agree on. I hope so. And
Certainly.
of course, getting pictures of stars is nothing new. That actually gets us to our first of this week's space and astronomy history. Do you want to take us away, Quentin?
Absolutely. Thank you. So on July 17th, 1850, that's 173 years ago today, that day marked a very early milestone in the field of astrophotography. This was when the first photograph of a star outside our solar system, so not the sun, was taken. The star in question was Vega, which is the brightest star in the constellation of Cygnus, the Swan. And the photo was taken by William Bond and John Adams Whipple at the Harvard College Observatory. So the photo was taken using a method called the daguerreotype process. And this is the earliest form of photography that was available to the public, and it was popular in the 1840s and 50s. So the daguerreotype method was developed by the French photographer Louis Daguerre in 1839, and it used a sheet of silver-plated copper that had been polished to a mirror finish as the surface for the image to be imprinted onto. It was a really involved process. It really shows you how much the field of photography has moved on since then. So not only did the photographer need to make sure the metal sheet was really well polished, but they would then need to treat it with fumes in order to make it photosensitive, expose it using a camera to focus the light until the image appeared, and then expose it to fumes of mercury vapor in order to make the image visible. And then, once you had this visible image, you had to seal it behind glass so it wouldn't get damaged because the surface was very easy to mar. The exposure time for a daguerreotype varied. A brightly sunlit object could be captured in a few seconds, but a much dimmer object required much more time. So in order to even begin to take images of astronomical objects, a lot of technological problems had to be overcome. A telescope needed to be able to focus the light from the object onto the plate, and it had to track the object across the sky for the entire hours-long process of acquiring the image. This meant that inventors needed to build new, more accurate clock drives that could keep the telescope rotating at a constant rate, as well as more rigid telescopes and more reliable telescope mounts that would not allow the scope to sag out of position. Daguerre had attempted to photograph the moon in 1839 after inventing his new technology, but tracking errors turned the photo into a fuzzy spot. The first successful photo of the moon was captured only a decade before the image of Vega, in 1840 by John William Draper, and the exposure time was 20 minutes. 20 minutes for one image of the moon. This was the birth of the field of astrophotography, a vibrant discipline that plenty of amateur and professional astronomers, including us at the Allan Carswell Observatory, still love to participate in today.
Absolutely. And of course, the progress of astronomical photography has been exponential, I would say, in the last couple decades with the sort of incredible high precision large pixel devices that we have now. A lot less toxic.
Yeah, that is nice. I'm glad that I don't have to inhale mercury vapor when I'm developing an astrophoto image.
Yeah, don't inhale mercury vapor. It is I remember that from my chemical safety class. It is actually very, very toxic, and a lot of old photography chemicals and actually even modern film photography chemicals have to be handled with some care. The movement from even just from plate photography into pixel photography wasn't possible for, a long time because we didn't have the miniaturization of electronics that we needed to be able to do better than film. Of course, now we do, and the wonderful pictures coming out of JWST can sort of thank the, thank the 1850s with William Bond and John Adams Whipple for
I
their.
think if you had gone back in time and you had told Daguerre that in under 200 years, everybody pretty much would be walking around with a miniature camera in their pocket that they could just pull out and take an image whenever they wanted, he wouldn't have believed you. It's crazy like how far we've come in comparatively a very short amount of time.
Yeah, well, and it's also the differences in technique because the way that the first photos were made, the silver-plated copper and treating it with fumes and all of that stuff, if you were to try to keep doing it the same way and insist on the same process, you never would have had that jump in development. So it's kind of cool that we've managed to come at it from a very different angle and get different results. And of course, Vega and bright stars are something that if it is even reasonably clear, you can see. So if you want to find Vega, it's in the constellation Lyra. And if you've got a good planisphere, you just need to line it up to find out when Lyra is up for you, and you can also see Vega. It's also, I think, the first star to have its spectrum recorded. So this was the first star photographically taken.
Yes, that was also mentioned in.
Yeah, that was Henry Draper took the first spectra, right? And so it's
yeah, that was a whole other field of astronomy that was essentially that was started right there.
And
very,
you want to
very
talk
important
about
field of astronomy.
challenging techniques. Make your life a lot more difficult. Make the light a spectra, and then try to take a picture of it. Anyhow, good fun. So let's see what other kinds of interesting things we can get into in history. I will stay in the 1800s and go just back a little bit to take us to 1826, which was actually, the 1800s, a very active time for a lot of different reasons. But in 1826, it was sort of a little bit of a sad time. It was the end of a famous asteroid explorer, Giuseppe Piazzi, who passed away the 22nd of July, 1826. If I'm saying that right, yes, 1826. So it's this week in history a long time ago, much like yours. And Giuseppe Piazzi, he was 80 years old, so he did have a long and fruitful life. He was a incredibly famous sort of asteroid explorer, and he was actually kind of the first one of the group of the real first asteroid explorers, because when you were looking at the ancient skies, you saw stars and planets and comets, but what were things that weren't stars and planets and comets? Well, asteroids were not really commonly thought of. It's like, okay, rocks in space, but that's probably just a, different kind of comet or something. So it's part of an interesting thing in history that we've actually talked about before on the show, the Celestial Police. So he was a member of the Celestial Police. So officially, the United Astronomical Society, the Celestial Police had various different names across Europe. This was a group of astronomers working early in the 19th century or in the 1800s, as the dates are strange. So this was with the express purpose of finding additional planets in the solar system. So this was inspired by William Herschel, who had discovered Uranus, the planet, or St. George's planet, as he wanted to call it. So this discovery of a planet that had not been seen before, not been seen by the naked eye, was huge. It was groundbreaking. There could be other planets out there, but we're going around our star. Crazy. So the Celestial Police were on the task, and this was a group founded in 1800. So basically, he set out German astronomer Franz Xaver von Zach, I think. It's probably saying that a bit wrong, but this was under Willem Olbers, and he set out to find missing planets. So they wanted to find anything else that was missing, and so they actually used the Titus-Bode law, which had predicted something in between Mars and Jupiter. There was nothing found there. That's actually where the asteroid belt is. So, concentrating their search in that area, they then started to find asteroids. And Giuseppe Piazzi was one of the founding members of that group, and he jumped in and found Ceres. So, if you haven't heard of Ceres before, it's not just an item from mythology. It's actually the name of a dwarf planet in the asteroid belt. This is a large object in the asteroid belt, now classified as a dwarf planet because of its fairly large size. It's circular. It's got, not enough gravity to circularize itself, and the mass is about 0.00016 Earths. So it's a fraction of Earth's size, around a hundredth of the moon's size, but still massive enough to be a circular object, and it's much larger than anything else out there in the asteroid belt. So this discovery of Ceres was very, very exciting because, it's very small, but large enough to be maybe a small planet. So Ceres is the largest object in the region of the asteroid belt, and over the next couple of years, other members in the group found Pallas, Juno, Vesta, and they found a whole bunch of these really, really small-sized objects. So it became apparent that no planet-sized object really was in that area, and the search kind of petered out, and around the 1803 to 1815, and then we had the Napoleonic Wars in Europe, so that was a disrupting force, shall we say. So the Celestial Police overall had about 24 members who were out there searching for planets, basically. And of course, finding Ceres was a great victory, but it didn't last too much longer than that. Giuseppe Piazzi, he went on to do all kinds of things. He actually was a very interesting character in and of himself. As I say, he did pass away at the age of 80, so he had time to do a lot of different things. He took the chair of mathematics at the University of Malta. He, apparently studied in Turin, and he was, had several different positions in math and astronomy. He went and visited the Palermo Observatory, and he actually did design some instruments sort of specially built for that observatory. So if you ever had a chance to go see, or read about the Palermo Observatory, he would have seen the name Piazzi. He was able to have all kinds of different interesting things that were happening around him, and of course, discovery of Ceres. He also supervised the Palermo Catalog of Stars. So this was another attempt to work the sky methodically. In the 1800s, he got 7,646 star entries, which was being done by hand using, technology of the 1800s. So this was extremely high precision and painstaking work. So he actually studied several stars to find parallax measurements, and 61 Cygni was appointed as a good candidate for finding a parallax. and this is sometimes called Piazzi's flying star or Bessel's star. So there's all kinds of interesting things going on at that time, not just Ceres. He did not, find any other, planet-like objects, unfortunately. So nothing larger than Ceres, but had a very, very successful career in astronomy and, of course, mathematics. And using the Titus-Bode law to predict where planets would be was something that astronomers tried several times. So it's kind of an interesting little part of history, an interesting little part of asteroid history in particular, for sure. And it shows a little bit about, I don't know if you've listened to the show before. I think we've talked about the celestial police, but if you haven't heard about them, it's kind of a fun piece of astronomy history. It's not every era that gets its own celestial police. And this, asteroid boom really started off with Giuseppe Piazzi and his discovery. So we have him to thank for, I suppose, the popularity and some of the interest around the asteroid belt. All right. So speaking of asteroids, I think I'll use that to say onwards and outwards from Ceres. I believe there's a slightly more recent asteroid discovery that you have in mind.
What an excellent springboard. So we're talking about the discovery of Ceres. Now we're going to talk about a much more recent event that really elucidated the nature of Ceres and helped us learn a lot more about it. And I am, of course, referring to July 16th, 2011, which was 12 years ago. This was the first satellite that was put in orbit around an asteroid belt object. Now, it wasn't Ceres, not at first. It was Vesta. Vesta is the second largest object in the solar system. Dr. Hyde, I believe you mentioned it in passing. Vesta is the second. It is either the largest asteroid or the second largest asteroid in the asteroid belt, depending on your definition. There's some ambiguity as to whether Ceres counts as an asteroid or not, as I understand it. But Vesta is not massive enough to take on a spherical shape, unlike Ceres. It's a roughly ellipsoidal object, and it's got a mean diameter of 525 kilometers, so certainly nothing to sneeze at. So the Dawn space probe was a space probe that was launched in September 2007, and its aim was to study Vesta and Ceres. So these two targets were chosen not only because they are both protoplanets in the asteroid belt, but also because of their contrasting chemistry. Ceres is an icy body, while Vesta is very water poor. And the NASA scientists were hoping that the Dawn mission could provide clarity on under what conditions a rocky object can hold water. So after entering Vesta in orbit on July 16th, Dawn remained there for a year until September 5th, 2012. It then entered orbit around Ceres on March 6th, 2015. So completing all of its mission objectives, NASA extended Dawn's mission until the depletion of its hydrazine fuel, leaving it in orbit around Ceres to gather more pictures. The mission ended when the fuel was depleted on November 1st, 2018, and it remains in a stable orbit around Ceres to this day. NASA researchers now suspect that the two objects took such different evolutionary paths because they did not form within the same region of the solar system. Ceres most likely formed in between the orbits of Jupiter and Saturn before being tossed into the inner solar system by the gravity of one of these gas giants. And this is consistent with our understanding of the distribution of water in the solar system. Due to its low heat of vaporization and its light mass, water ice would have been preferentially sorted to the outer solar system in the very early period of its formation. And the reason why Earth has so much water is because there was a very long period where Earth underwent a lot of collisions with icy objects originating from much further out. So Dawn was the first spacecraft to orbit two different extraterrestrial objects, and it was the first spacecraft to orbit a dwarf planet.
Very, very fun, and of course, it's worth mentioning as well with your talk of Dawn going through, Vesta and Ceres. Ceres as we talked about before, is a small fraction of the mass of Earth and slightly larger fraction of the mass of the moon. It's only 939 kilometers in diameter. So you could drive across it in theory. Vesta is almost half that at 525. And it's sort of got a whole, there's a few other Vesta-sized-ish objects, but it gets only smaller from there. And so, you've got one large object and then a lot of really, really small stuff. And the thing that is interesting about asteroids, and that's, one of the big things that changed, of course, when we went from, the 1800s to the modern era, as people started exploring the asteroid belt more and more, we found that the little stuff, it's not really all that much, it's not really all that closely grouped together, shall I say, because when you talk about an asteroid belt, a lot of times, in science fiction, you'll think about the spacecraft dodging and weaving to avoid all the rocks. That's not what's out there. It's one small space potato and then just lots of emptiness. So we do have, a few large things, but the amount of space between these things out in the asteroid belt is huge, which is why, craft like Vesta that could, go and see these things has trouble reaching a lot of different targets, right? Because we can't get to that many of them. Vesta and Ceres and, I think, what else did Dawn get to? Was that it?
I believe it was just the two. There were other missions that explored other asteroid belt objects, but Dawn, I believe, only visited the two objects.
Yeah, and it did. It had closest approach on Vesta, and I think it you said it went into orbit on Ceres, right? Because it did actually produce a full color map, which was really, really something to go and look up if you haven't seen it before.
It is apparently still in orbit around Ceres.
Is it still active? I thought it.
Well, no, it's not still active. It's just in a stable orbit, so it should remain in orbit around Ceres for the at least for the immediate future.
The uncontrolled stable orbit. Yes.
Yeah. I don't know for
sure.
I imagine if it gets ejected or if it collides, we wouldn't know. But
someone should send a spacecraft to check on Dawn.
Yeah, do a little checkup mission.
And honestly, we should go back to Ceres anyways, because it's far too interesting to be left alone for so long. Anyway, more space missions. That's my 2 cents.
Yeah,
speaking of space missions. So going downwards in size, I suppose, we're talking about most of these objects being tiny, 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 tiny. So Ceres, very small compared to Earth or the Moon. Vesta, less than half the size, and everything then that gets, we're talking about car-sized or maybe building-sized. So I'm going to do my This Week in Space and Astronomy History for my next item, July 17th. Last year, actually, 2022, we had a flyby, 6.1 million kilometers of an asteroid, 2022 KY4. And this is one of the Earth-crossing asteroids, which of course those ones are not contained or restrained, shall I say, to the asteroid belt. These ones are things that will go across Earth's orbit. So we want to watch out for those, because if one of them is going to hit us, we'd like to know about it. This asteroid did not hit us. It came at 6.1 million kilometers. So that's several times the distance from the Earth to the Moon. And it actually has a repeating orbit. So it came by in the 1940s and 50s, sometime around there. We didn't see it then, but according to its orbital trajectory, that's when it would have come by. And it should come by again in 2048. So that's not so long from now. So if you can hang on for another 20-some years, you'll get a visit from KY4 in 2048 and again in 2051, actually. So there'll be sort of a double chance to see it. The 2022 encounter last year was actually its nearest visit in about 100 years or so. Just as a comparison, one of the largest asteroid encounters we've had in recent history was one called 3122 Florence, which was about 2.5 miles to 5.5 miles wide. So that's a large flyby. And if you want even bigger scale, the asteroid impact that is thought to have caused the extinction of the dinosaurs, based on the crater remnants that they found, is thought to be something like 6 miles across and 110 giant crater, giant crater in the ocean, sort of remnants that they found. So about 6 miles across, you're looking at a sort of extinction level event asteroid. So that's the ones you really want to avoid. But this one, KY4, was not so big, sort of skyscraper sized, missed by a few million miles, and just as a reference, something like a 50-story skyscraper. So it's not tiny. It's not like a car-sized object, but it safely misses by about 16 times the average distance from the Earth to the Moon, so about 6 million kilometers. So that's a lot farther than the other asteroid, 2022 NF, which came about 56,000 miles or 90,000 kilometers. It's about 23% the distance from the Earth to the Moon on July 7th of 2022. So there have been little asteroids flying around in Earth-crossing orbits, and the great thing is that we're able to see so much more of them now because of the better technology that we have, or the better telescopes that we have for watching Earth-crossing asteroids and finding these small objects. They are very, very challenging to see. So you might wonder why have we not had so many asteroid reports before? They tend to be lower albedo objects. They're small, and they don't reflect that much light from the sun. So getting any signal off of them is a challenge. So a lot of interesting asteroids have come by, and this one just sort of caught my fancy because it's a small one of these little asteroids with very, very strange shape, and won't be making another close approach to our planet until May 2048. But it's one of many that are Earth crossing that we're trying to watch for. And you've probably heard about the DART mission, which slammed into Didymos Deiformos system also last year successfully. The idea is, and that actually was a hugely successful test, if you haven't read about it, asteroid redirection. So if you can find these things far enough away, and if they're going to hit Earth, the DART mission, which was the double asteroid redirection test, slammed a spacecraft into Didymos Deiformos, which was a 525-foot wide asteroid, so on the small size, but they were able to noticeably affect it. And that means that maybe if we get good enough at asteroid pool, or whatever you want to call it, pinging spacecraft off of asteroids, you can affect their orbit enough so that you could redirect something that was potentially hazardous so that it wouldn't crash into Earth, which is a really cool idea. So there's all kinds of cool asteroid watching apps that you can get if you want to follow along with 2022 KY4 or any other Earth-crossing asteroid that you like. Just as a little side note, one of the other things that makes these objects hard to find is not only are they small, but they tend to kind of zip past pretty quickly. So the speed of asteroid 2022 KY4 that came by last year was estimated at about 16,900 miles per hour. So it's just a fun little comparison. it's 8 times faster than a speedy sniper rifle. So it's going fast, literally faster than a speeding bullet. So I don't know if that makes it more or less like Superman. So asteroids are fun to watch if you're on spacereference.org or any of the other space sites. You can always get all of the asteroid details and the orbital periods and all that fun stuff. So 2022 KY4 this time last year went zipping past at faster than a speeding bullet, small to average sized, and we got a very, very good characterization of it and its orbit. So just hang around for another 20 years and should be able to see it come back.
I wanted to mention, just kind of in passing, you compared, as a point of reference, you mentioned the crater, the asteroid impact that led to the extinction of the dinosaurs. And we believe that created Chicxulub crater in the Yucatan Peninsula in Mexico. That's the second largest impact crater in the world that we know of. Do you know where the third largest one is?
Ooh, astronomy trivia. So the Chicxulub crater is buried underneath, and you can't. This is not something you can go and see, listeners. This is something that is well hidden underneath Earth's topography. But where would the number 3 be?
Should I tell you?
I want to say Meteor Crater, Arizona, but I know that's wrong.
No,
so
that's
tell me.
That's not it. That's significantly further down the list. It's in Sudbury.
Oh, right.
It's the Sudbury Basin. So the reason I bring this up is actually Sudbury is a city in northern Ontario, for anybody who isn't aware, which is like an hour drive away from Killarney. So I had to take a detour up there to get some business done a few days back. I ended up going on a trail like near the Sudbury area, and there's a waterfall that leads down on the outer edge of the Sudbury Basin. This huge ancient meteor impact from the Paleoproterozoic era, so 1.8 billion years ago. When this asteroid struck the Earth, all of the life on Earth would have been unicellular. But it's an absolutely fascinating area, very, very nickel rich, because of course, after it struck the Earth, it led to this huge magma plume, which is the reason why Sudbury is such an important mining town today. But I took a bunch of images of the trail that I hiked when I was in Sudbury. They are also included on the blog. So I figured I saw an opportunity for another plug for the Air blog. So I wanted to just kind of slip that in there.
Oh, absolutely,
largest,
absolutely.
Way,
and I can't believe I got that wrong because we have Professor Mary Helen Armour coming up as one of our astronomers in residence.
There you go.
She would tell me that, of course, this one is one of the largest. So I just have a terrible sense of size. That's it.
The largest one, by the way, is it's called Vredefort, and it's located in South Africa. So that this is just some meteor impact trivia for you.
Yeah, and there are some really interesting things you can find around in Sudbury, the Sudbury area geology as well. So if you're interested in, different kinds of igneous rock and, fun impact geology, as well as actually some volcanic geology. It's a wonderful, wonderful place to look for all kinds of stuff from like quartz to I think different kinds of graphene and all kinds of great stuff. So yeah, and isn't there's the igneous is not part of the impact. That was a melt sheet, right?
Well, the entire Canadian Shield used to be a very very tall mountain range. Actually, they got worn down over the course of several ice ages. So at a long time ago, this whole area would have been volcanic. So that is one reason why there's igneous rock in the area. But I do believe when the Sudbury impactor hit, it also released a lot of magma that was free to flow to the surface of the Earth, and that's the reason why, for example, there's actually so many heavy metals in the soil in Sudbury that it creates a gravitational and magnetic anomaly
Yeah.
that is measurable. So I believe that I don't know if researchers are entirely sure, but there is a popular theory, at least, that the impact had something to do with that. Um, yeah, I don't know the details. It's a very complicated topic because we're talking about uh, like a billion years of geological history here.
Yeah, yeah, and it's got all kinds of great astronomy and geology connections as well. I know one thing about that site that I had heard is that it was actually used to train Apollo astronauts
Yes.
to recognize breccias.
Yes.
So that I had heard, and that's so if you like Apollo missions or moon landing stuff, and you just want to see rocks that have resulted or formed as a result of a large impact. That's it's probably easier to get to that one than the one out on the Apollo landing site. Um, so our own little bit of the moon here in Ontario.
Would you like to continue with This Week in History, or would you like to go to the news?
Well, you've got one more item, so a little bit of fun. I would hate to skip it because this is actually a little something different, but wonderful to read about. So I think let's go ahead and catch your last one. A different kind of little different kind of history.
Yeah, different kind of milestone. But when I found out about this, I figured it deserved to be acknowledged.
Oh
So on
yeah.
July 18th, 1980, India became the seventh nation in the world to launch a satellite into space with a rocket of its own making. This satellite was known as the RS-1. It was part of the Rohini satellite series. So the Rohini series consisted of four experimental satellites launched by the Indian Space Research Organization, or the ISRO, using their purpose-built rocket, the Satellite Launch Vehicle. The first Rohini satellite, the Rohini Technology Payload, was launched in 1979, but it failed to enter orbit. So it was followed up on July 18th, 1980 with the RS-1, on May 31st, 1981 with the RSD-1, and on April 17th, 1983 with RSD-2. So RS-1 remained in orbit for 1.2 years. RSD-2 remained in orbit for 7 years. RSD-1 was in orbit for only 9 days, and it was considered a partial success. This was because it did not reach its intended height like its predecessor and its successor did, but it did remain in orbit for several days at least. All four satellites were launched from the Satish Dhawan Space Center, which is near the city of Chennai. And the six nations to launch satellites before India were the Soviet Union in 1957. That's, of course, the famous Sputnik. The United States in 1958. France in 1965. Japan in February 1970. China in April 1970. And the United Kingdom in 1971. And then since India became the seventh nation, we've had Israel, Iran, North Korea, and South Korea. They've each launched their own satellites, as have Russia and Ukraine after the collapse of the Soviet Union. Italy and New Zealand have also contributed to the creation or continuation of orbital launch systems, and many other countries, including Canada, have built satellites that were put into space by rockets that were built by another country. So this actually happened to India as well, prior to its own launch. It had previously built two satellites, Aryabhata and Bhaskara Sega 1, which were launched by the Soviet Union in 1975 and 1979.
Yeah, and of course, Aryabhata is named after a very famous Indian astronomer who wrote probably the first official formalization of gravity. So it's totally great astronomy history there.
I did
And
not know that. I'm going to have to look that up.
yeah, I hope I'm not gonna get the name wrong, but I'm pretty sure that was him.
That's fascinating. Thank you.
The Indian Space Research Organization, or ISRO, has a lot of really great missions coming up. They've actually got a whole bunch of space telescopes and sort of super heavy launch vehicles planned and all kinds of really interesting stuff. So always fun to read about what other people are up to. And some of the spin-off technologies have really also proved incredibly valuable, as we've seen again and again, for engineering and medical industries. So yay space.
As if we needed another reason to cheer on the space program.
Yeah, we don't, but we'll cheer it on anyways. All right, everyone, you are listening to York Universe, broadcasting live from the Allan and Carswell Observatory located at York University in Toronto, Ontario, Canada. If you'd like to join us live tonight, head on over to yorku.ca/science/observatory and go on over to OPV or click any of the YouTube links. Our crew is on YouTube right now, Allan and Carswell Observatory, and they are posting pictures and chatting live in the chat. Of course, at 10 o'clock, all that will end, but it will be recorded. So tonight you are listening to Dr. Elena Hyde and Quentin Wayrich, and we're currently discussing all kinds of fun things, but in particular, some of the ISRO's amazing accomplishments. So that actually rounds off our This Week in Space and Astronomy history. I do have a special reminder for people listening this week, in case anyone else has lost track of space and time. Today is Monday, the 17th of July, 2023. This week on Wednesday, we have a very special Teletube broadcast with a guest speaker, which will be on our YouTube channel from 7:30 p.m. until 8:30 p.m. It'll be recorded as well, but we have the Allan I. Carswell Observatory's very own Maheen Hemani, who's coming in to talk about all kinds of amazing, fun research that she has done as an undergraduate at York University. So we're really excited to have her on, and come on by this Wednesday to follow along, ask questions, or just cheer her on. So that is this Wednesday from 7:30 p.m. live on YouTube. So that's a special reminder happening only this week. Great stuff. So
Fantastic. I can't wait.
Yeah, it's going to be fun. We will, of course, have in-person tours later on this month, so if you're waiting around for those, the Eventbrite tickets are on the website. So you can click on them and get them for free anytime. So let's go ahead and get a little bit of news into this episode. So we've been talking a lot about asteroids so far, which is great because the next news item is kind of a more modern approach to asteroids, i.e. can we mine them and all that good stuff. So final assembly and testing of Psyche is nearly complete. Quentin, did you want to talk about this one a little bit?
Oh, I'd love to. We talked about the Dawn spacecraft, NASA's mission to the asteroid Vesta. So now I'd like to talk about the Psyche spacecraft. So this is a NASA mission to explore metal-rich asteroids, and it's almost ready for launch in October of this year. So the final assembly, testing, and launch operations are underway after a 1-year delay to complete critical testing. So the solar arrays and the imagers still need to be installed. The trip to the asteroid will take about 4 years. The asteroid that it's approaching is also called Psyche. So very easy to associate the spacecraft with the object it's going to in this case. It should reach Psyche in August 2029. It should orbit for 26 months to closely examine it, as it could hold valuable insights into the formation and evolution of our solar system. Psyche, the asteroid, is in the outer part of the main asteroid belt between Mars and Jupiter, and is believed to be the remnants of a core of a planetesimal. It has a mean diameter of around 222 kilometers. Studying it could help planetary scientists learn about the early history and composition of terrestrial planets like Earth. So instruments on board the Psyche spacecraft include multispectral cameras, gamma-ray and neutron spectrometers, which are also known as GRNs, and magnetometers to study the asteroid's magnetic field, surface features, and elemental composition in great detail. We visited Vesta, we visited Ceres. We're kind of making our way down the asteroid belt chain. I believe that Psyche is something like the 10th or 11th largest asteroid in the asteroid belt, if I'm not mistaken.
Yeah, it's not very big. I do recall that. There are a lot of small asteroids, so I would have trouble remembering exactly which one, which position it goes on. But the asteroid, not the spacecraft, and this is going to be a problem with this mission, I think, is because every time you talk about it, you'd also talk about asteroid, not spacecraft. So the Psyche, the asteroid, is 16 Psyches, so it's a M-type asteroid, not to be confused with the Star Trek M-type planet. So it's massive enough that it can gravitationally affect other objects, but it's still very, very small. So its mean diameter, like not accounting for its strange shape, is about 223 kilometers. So this is roundabouts of half of what you were talking about with Vesta and the larger-ish objects. So because they're so irregular as well, you get these strange potato shapes, and they orbit in interesting ways. But yeah, I'm not exactly sure if it's where it is on the total number of asteroids we've found, because we're always finding more. So
Yeah,
I'd say your guess is
here,
as good as mine.
what it says here is it's one of the dozen most massive asteroids.
Yeah, that sounds like
So
a
top 12.
accurate. Yeah, that sounds like one of the dozen. That sounds like a more accurate estimate, because you never want to be like it's a 100% the 15th or whatever, because you're always going to find another asteroid in between there.
Of course, yeah.
And this was actually the 16 Psyche is the 16 is, I think, the new designation that they're trying to do on asteroids.
Yeah,
so
I believe it's
interesting.
in order of discovery.
Yeah, because they were trying to give them symbols, but then they realized there were way too many of them. Yeah, it is really, really interesting, of course, because this more metallic asteroid is a type that we haven't really explored very well. A lot of our other flybys have been of more rocky asteroids, so rather than metallic. And this one is still the heaviest, I think, or most dense as according to new estimates. But it's a really interesting mission, and of course they're underway. So we always hope that it won't be delayed. So fingers and toes crossed, but it might launch on time. So
it'll launch eventually. That's all we really need to worry about.
Yes. As long as it launches successfully, and the latest launch date is still October 5th of this year, I believe.
Exciting.
So fingers and toes crossed for a lucky Halloween launch of Psyche to Psyche, and I think we have time for maybe one more little item. Do you want to talk about the actually, let me just really quickly do this little tiny asteroid, and then we can talk about satellite noise.
Perfect.
So there is one more funny little piece of news that's happening right now that you might not have heard of, but there is actually an asteroid that is on the menu. So the airplane-side asteroid was found about 2 days after a little brush past Earth. So this is July, July 16th. So that was it's been known for a couple days now. This is the 17th, so I believe it's been known for about a week or so. On July 15th, the ATLAS, or Asteroid Terrestrial Impact Last Alert System, noticed an asteroid about 200 feet or 60 meters 2 days after it passed close to Earth. So this is a recent asteroid, much smaller than anything we've been talking about. And the asteroid alert systems and the asteroid sort of alerts for things crashing into Earth have gotten really, really good recently. So this was not a threat for Earth, but because it came at us from the direction of the sun, we could not see it until it had already gone past. So this is a known weak spot in our asteroid detection system, and something to keep a little note out for. So this particular asteroid is 2023 NT1, just in case you want to check it up. It is already past, no danger at all. And let's go ahead and quickly talk a little bit about some radio noise, because one of the things that can help us see these, at least some asteroids, is a good uninterrupted view of the sky, as long as they're not coming from the direction of the sun. And one of the things that is really affecting that quite badly is the satellite constellations. So, yeah, Quentin, do you want to? We've got about 5 minutes, so I'll let you talk a little bit about the radio noise.
Sure thing. So this is some unfortunate news. It seems that large satellite constellations generate unintended electromagnetic radiation in addition to the intentional communications transmissions these satellites generate. So scientists from a number of research institutions, including the Max Planck Institute for Radio Astronomy, use the Low Frequency Array, or LOFAR, a large radio telescope mainly located in the Netherlands, to observe 68 SpaceX satellites. For a long time, researchers have known that man-made sources of radio waves have the potential to interfere with radio astronomy efforts, so many radio telescopes are now located in radio quiet zones to prevent this interference. This is a pretty good job of restricting interference from ground-based sources of radio waves, but what about satellites in orbit? There are thousands of these satellites now, which means that any radio telescope will have many satellites radiating signals in its view at all times. Examining the SpaceX constellation with LOFAR revealed that 47 out of 68 of them were emitting detectable radiation with a frequency between 110 and 188 megahertz, which includes a band between 150.05 and 153 megahertz, specifically set aside for radio astronomy by the International Telecommunications Union. So while ground-based radio sources have strict regulations preventing this kind of interference, no such rules currently exist for radio sources that are located in orbit. And simulations indicate that as satellite constellations grow bigger, this interference effect will become more and more pronounced as the signals from the different satellites add up. The researchers are calling for collaboration between radio astronomers and satellite manufacturers to reduce the impact of satellites on our ability to image the universe in the radio band. They're already in close contact with SpaceX, who are reportedly discussing ways of mitigating any adverse effects on astronomy in good faith. They are hoping that the rest of the industry will follow their example and move forward in a spirit of collaboration.
Yeah, we all very much hope that, because there are many, many reasons, not just asteroids, that you want to get a clear view of the sky. And having not just the occasional optical flyby going through your images, but also having radio wavelengths obscured, does all kinds of things to your ability to map the sky and find stuff. So I don't know, we'll have to get some of our space law friends to help us out on this particular issue. And you know, it is unfortunate because there are already thousands of these satellites out there. So this is something that we're going to have to really work on as a scientific community, I think.
Yeah, certainly.
Well, now that we've scared everybody by talking about asteroids and telling them about the radio blindness of our telescopes, let's just go ahead and remind everybody that it is, in fact, not very likely that we'll be hit by an asteroid. And despite all of this, our asteroid detection systems now are actually still better than they have ever been. And we've even seen things like that bolide meteor that came and flew by the CN Tower not too long ago was actually detected as a warning in advance. So a little bit of good news to end off the show. All right, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. The hosts this evening have been our astronomer in residence, Quentin Wayrich, and myself, Dr. Alina Hyde. Stay tuned, because it is Science Night in Canada. Coming up next is Western Worlds, Quirks and Quarks, and Science for the People. You can always connect with us on Twitter with the handle @YorkUniverse, Instagram with @YorkU Observatory, and Facebook at Allan Carswell Obs. Check our website for show notes, content, and updates at yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe.